First thing that I did in performance tuning was working at a manufacturing plant. We did what was called Dry View, which was a medical imaging film, and this was in White City. And we worked in the dark. So we had red lights on, it was really dark. We had these big rolls. This is about as tall as a person, each one of these rolls. And they come in two colors. They come in a blue color and kind of a clear color. And the challenge is that if you put them on the coder and you had the wrong color, you had the possibility that you could lose about $30,000 in production because you were putting the wrong coating on the wrong color. And so working in manufacturing there, we had PLCs that were controlling the machines, and then we had computers, and this was back in like the 2000 range. That's kind of what the computer looked like. And that had all the business information in it. It was connected to a SQL Server, but knowing what color a roll was in the business system, and making a decision on whether or not we could use it was in the PLC. So I ended up building a interface between the two, and it was a service that had to do continuous data exchange, and this cycle for each exchange needed to be less than 30 milliseconds, and it needed to keep up with it. So back in 2000, I was doing really tight constraint performance work with .NET and SQL Server. Since then, I have been learning quite a bit through different people. Joe Knoll was my first mentor in performance tuning, and he helped me with quite a few different customers, and he seemed to have this endless checklist of things to go through and check in SQL Server, and that was super helpful. And then he pointed me towards Glenn Berry, and Glenn Berry has a set of SQL scripts, and we use these quite a bit. There are about 70, 75 different queries that we do on SQL Server to be able to see how the SQL Server is performing, to do, we call it our SQL diagnostics. Recently, I've been looking at material from Brendan Gregg and systems performance. He's kind of in the Solaris Linux world, but this particular book goes through systems in pretty detail beyond SQL Server. And then finally, Clint Huffman has got a book called Windows Performance Analysis Field Guide. And again, this is more Windows focused, but it goes in and it was written in like 2012, and it goes in and talks about perfmon counters in particular, and different use cases and possible problems that you can have on the Windows system. So that's kind of the work that I've been doing to bone up more and more on performance, and where I came into wanting to do perfmon counters in Power BI. So kind of an overview of how I think about performance tuning. There's really three things that I think about when I think about performance tuning in particular in terms of doing analysis. So we have application performance monitoring, which in the 3 ERP systems that we're dealing with, we don't really have an easy way to do that. But it's essentially at the user level, how long is the user waiting for each action that they're taking? And then system performance monitoring. This I think of looking at all of the systems. So all of the boxes that are involved in the system, being able to look at the perfmon counters and look at the hardware performance, and even to going in more depth. A lot of our systems are virtualized, and being able to look at the performance counters at the host level, so that we can see, are there bottlenecks in the hardware or configuration. And then the last one is SQL diagnostics, and that's what we've been doing for a long time, using the Glenn Berry scripts, using SP Who is Active, and then looking at more tactical pieces of information where we're going and looking at query plans, indexing, etc. So the SQL diagnostics. So those are kind of the three things that we use to analyze systems. And then when we have done that analysis, there's really kind of three areas where we make changes. We make changes in the hardware, so bringing more memory on board, bringing more processors, changing what we're doing with the disks. Configuration changes, taking the existing hardware and reconfiguring it in a different way, maybe using a different driver for your network connection or your iSCSI to be able to get better throughput. And the last piece is query tuning, which is really our indexing, our changing our code, and specific tactical things that we're doing to improve things. Configuration changes also includes reconfiguring the SQL Server, so changing our max degree of parallelism or our cost threshold of parallelism or our max memory, mid-memory, those type of configuration changes. So in this session, what I'm going to do is I'm going to go through some example visuals, and then I'm going to go through the mechanics. And the mechanics is really something that I would like folks on our team to really grab a hold of. There's certain steps that it'd be really helpful. I know that Sean and Chris are already doing some of this, but being able to get the data collector sets in. So pay attention, especially in the mechanics. I'm hoping to spread that out among the team. Then we'll look at Power BI and creating visualizations in Power BI, and then we'll take a look at the package that I put together in Power BI that we can use to do basic analysis. So here are some of the visuals that I've been coming up with in Power BI. This example one is a heat map of processor time. And essentially what I'm doing is I'm doing 1 hour bins across a full day. And then this particular machine has 40 processors that are on it. It's a SQL Server, and I'm looking at the percent processor time counter. The thing to notice about this is if they're running standard, SQL Server standard, they're paying for 40 cores, and they're actually only using 16 cores. We only see traffic for SQL Server really from 0 to 16, and the primary piece we see most of the work is being done on processor 10. In this particular machine, it's an X3 box, and the application, the runtime is on the SQL Server, same SQL Server. So this is actually what's happening with the runtime. We've got 1 core, and then we essentially have 40 cores that are, or 30 cores that are not being utilized at all. Next visualization is a multi-line map. And in this particular one, I'm looking at average disk seconds per write. And this is showing me disk latency. Our concerns go in disk latency when you're over 20 milliseconds. This is showing in seconds. So these little spikes are occurring are like 0.3 of a second. And it occurs at the same time every day during the middle of the week. So that indicates that we've got a heavy usage that's occurring on this machine every day in the middle of the week, probably about 3 o'clock. And this particular multi-line heat map helps us draw into occurrences that are recurring at a certain time and getting us to a certain level on a certain drive. The third example is user connections. We love to know when people are using the system. The SQL Server counter user connections shows when they're made, and this really shows us that on this system between 6 a.m. and 6 p.m. is when the users are on the system, and there's a little dip that occurs right after lunch. And then there's some time where over the weekends where it's not being used at all. The third example, or the fourth example, is our workload based on the database on the system. So this is really helpful to see which databases are causing what type of load. The donut chart gives you an idea across the entire time that you're looking at where the load is coming from, and we can see that the majority of the load, 77%, is coming from the X3 V7 database. And we can also see the other databases that are causing some load. And you can see it across time. Are there particular times where we're seeing spikes in load, and each color represents a particular database. The fifth example is processor queue length. So processor queue length is when the scheduler on the machine, and there's only one scheduler on each machine, when it doesn't have a core to be able to send a particular process to. And it may, the scheduler may say, hey, because this process, this particular thread needs to be scheduled on the same processor as a previous, we may see saturation here. The spikiness of this is important. So when I see spikes that just go straight up and straight back down, I'm not concerned with that. Again, when I do the data collection, we're at 30-second intervals. So if it goes up and down in 30 seconds, most likely somebody's not waiting for very long. It's when I see a plateau that I'm concerned, because that indicates that I've got a user waiting for, in this case, it could have been 2 or 3 or 5 minutes for a particular process. So it indicates that we've got saturation that is occurring on the system. So processor queue length. We're going to talk about the mechanics. And actually, before we go that, any questions on those particular visualizations? They're just kind of examples of some of the visualizations I'm coming up with in Power BI.
Yes, looks like Kyle has a question about threading. Single versus multiple, is that the determining factor which allows the processor to switch?
So I have, from a threading perspective, especially for X3, I haven't figured out how it determines whether or not it can switch it off. I know that Node is controlling which process it is connecting to on the runtime, and you can have multiple runtimes going. I think if a particular session is connected to a Node session that goes to a runtime session, I think all of that stays together. And so if you've got multiple requests that are occurring in there, it has to occur on the same processor. I haven't proven that out yet.
Okay, Kyle seems satisfied. Thanks, John.
Yeah. Okay, so mechanics. The first thing that we're going to do is we're going to create a data collector set within perfmon. Then we're going to move the data analysis to, move the data to our analysis machine. We're going to bring, we're going to set up the perfmon SQL database, import into the database. Then we import into Power BI and analyze the data. The reason I'm putting this in a SQL database is, well, I mean, first of all, I really like SQL databases, and that's where I like my data to live. We could import directly into Power BI, as in Power BI, it does store data, but I'm not sure exactly how much data I'm going to store. If I'm just getting a baseline, I may keep that in my SQL databases. I can do backups there, and then I'll bring it into Power BI for analysis. So this is just kind of my route that I go. There are other paths. So creating a data collector set. To launch perfmon, you can just go into your search bar, or you can launch perfmon. You should all be relatively comfortable with that. There is a console tree that shows with perfmon. You'll have a node that's data collector set user defined. To create a new data collector set, you're just going to click on new, and then you're going to name it. And we're going to create from a template. You can create it manually, but it takes a long time to add all the counters that we want to add to it. You're going to click next, and then you're going to browse to the XML file, which is our template, and bring that in. Click next. You're going to choose a location to store it. Usually I put it on the C drive in a folder called perflogs. Then I will make a name for my machine for there. I run it as default, and I want to open up the properties for the data collector set. You can see that the data collector set is created and it's stopped. You can see the directory that it's being saved to, and then as it runs, it will create a new directory with a year, month, day, and a serial number. The serial number is going to start at 1. From a schedule perspective, it defaults to come up to start every day at 12 a.m. It begins, this is saved in the template, so we can go in and we can edit that and just have it start tomorrow morning. Usually, so that's usually what I do is I just bring it in and then I adjust it. The stop condition, their overall duration should be 1439 minutes, which is, we've got 1444 or 1440 minutes in a day. So that gets us just 1 minute prior to the end of the day. If you get this account dialog box that comes up, you can just remove the username and the password. I tried to troubleshoot to figure out what permissions we need to get that to work. I haven't been able to figure out what permissions. There's 2 permissions in policies that are related to perfmon. I've given myself both those permissions and it still comes up. So maybe Ken or Jason or Brandon has a magic setting that we need for that. The next thing to do is to go into the data manager. So the data manager, this should be set up properly for you. It's essentially set up so that we're not collecting too much data. So it says if we get beyond, or if our minimum free space goes below 1 gigabyte, then it will stop collecting. And then when it starts the task each day, it's going to apply this policy before it actually starts collecting data. What it does is it says for anything that's collected in the past, after 2 days, I'm going to create a CAB file. After a week, I'm going to delete the data file. I'm going to delete the report. And after 30 days, I'm going to delete the CAB file, the data in the report. That just makes sure that my data stays clean. Finally, I need to go into Task Scheduler. So when you create the data collector set, it creates a scheduled task. And it's creating it differently on this machine. So Windows, yep, there we go. And PLA. I'm going to do properties. So this is the location where the data collector sets are always stored. The task for them is under this PLA node. I want to set up a trigger. So we'll create the weekly schedule, so it's starting it every day. But if I power off the machine and start the machine back up, cycle it, it's not going to collect data until the next morning. So I create a new trigger that says, if I start up, I'm going to start this data collector set up at startup. And then I change my settings. And this is just to protect it. So if for some reason it runs for longer than 3 days, I want to go ahead and stop it. And then if there's an instance running, I want to stop the existing instance and start a new instance. From there, I can right click on it and run it. And that's creating the data collector set. And I actually have a video of this and a blog post that I sent over to Laura. So that should be going up on the website pretty quick, hopefully with the video. So that's probably the most complicated process for each person to use. All right. We're going to set up a perfmon database to put this data into. There we go. So I've created a script, and there's a better visual of the tables that we're creating. I've got this performance monitor analysis script, which creates a few tables to store the data, and it creates a stored procedure that is used to ingest the data and normalize it. So you're going to create a new database, and I usually prefix it perf. Once you create the new database, you can point your script to the new database. And it's the first time that I ran it on this machine. There we go. Okay, so that will create the tables that we need. Just for the fun of it, we'll go over and look at the tables that we created. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 tables in the database. I'm setting these up so that I've got a separate database per customer. So if they want this data, we can send it back to them after we've parsed it. It helps us to just keep our customers separate. PowerShell is used to bring the data into this database. There is a file that is created. So the file that gets created looks like this. So it's either going to be a CAB file or it's going to be a BLG. The BLG is a binary log file, and you can't open up and look at it. It's the most compact way to store this data. About a day's worth of data on a SQL server is about 31 megabytes. To ingest it, the perfmon script essentially goes in and it's going to go in, and it's in a particular directory that you point it to. First of all, let's see, it's going to try to connect to the SQL server. This section in here is going to take a look at all the child items. It's going to extract the CAB files. It's going to find the binary log files. And then it's going to go through and it's going to convert it to a tab separated file. Then it will go through for each file that is a tab separated file in the directory, and it will work this recursively. It goes in and it loads all of this data into the perfmon stage table. The parameters that you're going to pass to it, and I've got an example in the script. Really, you're just going to run in PowerShell the BLG to SQL PowerShell script. You're going to point it to a particular directory. You're going to pull that data in, and then you're going to point it to a database you're going to save that data into. When you run it, essentially looks like this. Depending on the speed of your machine, it could take up to 3 minutes per file to bring in. So it's at this point, it's not the fastest. If you're ingesting a lot of data, you kind of let it go and come back. We'll look at optimizing this and get it multi-threaded if this starts becoming a bottleneck. At this point in time, it hasn't been a bottleneck for me, but it's but it is kind of time consuming. Okay, we've got the data in SQL Server, and I didn't run it just because of the time. Now we're going to bring it into Power BI. So I'm going to launch Power BI. When you launch it, it can take a little bit to run or to load up for the first time. And let me talk a little bit about Power BI. So Power BI Desktop is actually a free download available from Microsoft. They have a couple of different ways to deploy it if you want to have shared workspaces. But for what we're doing, we're not really sharing the data other than just sharing the whole Power BI file. If we start using Power BI quite a bit more, we can look at different options. But right now, because it's a free download, you can just bring it down. You can start analyzing your data with it, and it's really easy to do. I'm just using Power BI Desktop. So I'm going to get my data. I'm going to connect to localhost, and I will do perf test because that's where I brought the data in originally. Let's see if this will work. So it automatically connects that database and it shows me the tables that I want to bring in. When I click on the table, one of the tables, I'm not going to bring in the staging table because I want the normalized data. And then I'm going to load it in. At this point in time, it's actually loading all of the data that is in all of those tables into my Power BI. It's going to give me a layout of the tables, and it lays it out based on the relationships that I've defined. So my fact table is my perf data, and in it, I have the counter value. So that's the piece of data that's pretty critical. I have a date timestamp. When did that counter get recorded? Working out to get different pieces of information. So my instance key is going to run me towards my counter. So my instance is going to be like my processor number. It will be my process name. It may be my disk drive, the particular drive letter. The counter is going to be the specific piece of data that I get gathered. So that's like percent processor time. That's going to be my average disk seconds per read or average disk seconds per write. I store that in the counter table. And then we have the categories, and this is going to be processor or memory. The units is something that I'm working on. What's the unit of it, whether or not it's seconds or counts. The device is what machine, so it's the device name. And then this device instance I put in here so that in one visual I can look at counters across multiple devices. And we'll look at a visual that includes that. So that's kind of the data model that we have. If you want to look at the data, you can go into each one of the tables and you can see all of the data that got brought up into Power BI. You can see that I just have one server that I've brought in data in this particular report. And you can see where this device instance, essentially what I'm doing is I'm using the server name or the device name and the counter instance. And that'll be for reporting. The perf data is the big one. And so you can see the counter value, and a lot of these are 0, but if I scrolled way down this table, you would start seeing values there. And then there's a couple of calculated columns. So there's a date timestamp and a timestamp. And I'll be using those a lot in the visualizations. The date timestamp is the specific time that a particular value was recorded. And then you get to the place where you can create visuals. You have all of these visualizations that you can use. And I'm going to just demonstrate to you creating what I call an explorer. So the explorer is really allows me to look through all of the data that's available. The first thing is I'll put a line chart on there, and the line chart will be my biggest visual of this particular report. And allows you to configure that particular visual just with drag and drop. So my axis, this is going to be my x-axis. And on my x-axis, I really want my date timestamp. So I want to see all of my values across all time. And because I'm working with time series data, and I'm not really working in pivoting and wanting to do aggregations by year, month, day, I really want to just deal with date time. I'm going to switch this. There's two options. You can use the date hierarchy, or you can use a date timestamp. And for all of my perfmon data, I use the date timestamp. Let's see. Okay, so I'm still on that visual. I've got the x-axis. I'm going to bring my counter value into my values so that it will display my values. And I want to, at this point in time, it's doing a sum. That's okay. This is the sum of all my values across all of my times, which doesn't really make any sense at this point. So then I've got to add in some slicers. Slicers are automatically tied to visuals in here. So a slicer is saying, hey, limit down what I'm seeing. So I can drag a particular slicer into or a particular field onto my slicer, and it will let me limit what I'm seeing below. And let me get a few more on here so that it actually makes more sense. Magically, this will occur, and it limits down based on your slicers up here. And this should be, let's see, modeling. I'm going to try one thing. If it doesn't work, I'll go to the one that actually works. Yeah, it's not going to work. So normally that works. This is the first install of Power BI on this machine, so could be something having to do with that. Not sure yet. It's also a new version of Power BI that came down as of today. So hopefully this visual will work a whole lot better. So this is data that I loaded, and this is Parkseed data that we pulled in. And what I have is a Power BI session. It's a good idea. Ferdinand said, do I need to refresh it? And the refresh is actually getting data back from SQL Server. So it's not getting data from SQL Server. It has something to do with how the controls are connected together. So user connection. So these are visuals that I've put together that I think are going to be helpful across the whole team when you bring it in. It's got the same data model as what I had shown you. So user connections, this is a test system. So it's showing you each color is a different day, and it's showing you when there's connections to the database. Processor heat map, I think, is a good one because it shows you at what times of day we're seeing load. You can look at it across all of your processors or all of your machines, and then you can change the days. You can see that just by the color that this app C1 is more highly used than the rest of the machines. You can change the day that you're looking at. You may not see all the hours of the day depending on what you collected. So that's the processor heat map. The processor queue length, for them, it's not quite as interesting because we're going to see a whole lot of flat lines. Occasionally, we're going to see queue length pop up to 1, but again, it is really spiky, so it's not holding. Again, I'm looking for plateaus in my saturations. But I can go through each machine and I can see where I've got some amount of saturation. And I can see, app and proc are probably the ones that I'm more concerned about. Memory. So memory is same type of thing. It's giving me a line chart. It's I can look at my available megabytes in memory on my SQL Server. I can see that I'm typically running in the 10,000 megabytes, 10 gigabytes, which is probably okay from leaving overhead for the server and letting the rest of it be consumed by SQL Server. If I go through the rest of the servers, we're looking at a gig or 5 gigs or so that are available on the AC server. Quite a bit of memory available on the app server. A lot less on the proc server. That's pretty normal. They probably shut down SQL Server on that March 7th. As we're looking at the web server, we do see a trend where we get memory that's being consumed. I'd be somewhat concerned about it. I mean, it's got plenty, and we're getting a reset that's occurring each day. But if that were to ramp up, maybe we're going to start running into some out of memory issues on the web server. And very slight trend down on the MongoDB server. Disk latency. I like this particular visualization because it's showing me all of the disks at once, and it will adjust the y-axis. I've multiplied the seconds to 1,000 because we're dealing with milliseconds here. So here it would be, I'd start looking at if I'm seeing values over 20, so 20 milliseconds, I would be starting to be concerned about. And I'm looking that especially on my SQL Server. So on the ADC, again, we can see some spikes that occurred on Friday. We can see on the app server, and this is something that I don't know about X3 yet, is how sensitive the app server is to disk latency. In this case, we just see a spike here. It's running up to 10, not anything that I would be really concerned about. Same with the proc server. Again, it's running pretty low, a couple of spikes in there. Might look for some consistency day in and day out. So I'm not seeing anything really to be worried about from a disk latency. And that's something that's been interesting as I've been looking at Perfmon data. There's a lot of stuff that you look at that looks fine. And so it's trying to find those things that don't look fine. And it just takes a little bit of time to look through it. So the web server, that's running a little bit hotter than the SQL server. And the MongoDB, not bad at all. You can do the same thing looking at reads.
Hey, John, one question as I watch this, one question for you that I have is, this is all after the fact, but are there alerts or notifications when these spikes happen or plateaus happen that will notify the IT team at the time that they occur?
So you can set up alerting within Perf Monitor. You can put some alerts on it, and you can do it within SQL Server. For what we're doing with this, the intent is after the fact monitoring, trying to troubleshoot, so they don't have to call us. We can go in and we've got the data collecting, and they can say, hey, at 10 o'clock today we had a problem, and I can go back and look at the data.
Okay.
But yes, we can do alerting within the system. I showed you the example of the workload distribution. So this is an area, a stacked area chart down here. This particular SQL Server isn't as interesting because most of the load is coming from the Sage EM database. In fact, 97% is coming from the Sage EM database.
Hey, John, Ferdinand has a question too. Are there any guidelines, white papers, or reference material that will point us to some of the red flag numbers?
No, but I'm working on it. I've got a couple of blog posts that I want to talk about different performance counters and how to do the analysis here. I wanted to at least get to the analysis so that we can look at it, and then as we build some knowledge, especially by ERP system, we'll be able to say, hey, if you're seeing this type of latency, it's a problem.
Okay. Good. No other questions right now.
Okay. Didn't talk about this time slicer. The time slicer is actually kind of cool because what it can do is it can filter down the window of what you're seeing and allow you to drill in to certain times. So if we're looking at those particular spikes, I can drill in and I can see what happened at those particular times. And the date range slicer, again, right now I'm looking at the load from 3.5 to 3.9. If I want to focus in on a particular day, I can narrow this down. And you can change these slicers, the visual on them. Block processes, again, this one, I'm looking on block processes. I'm looking for plateaus. So I'm getting very short block processes. It's, at most 30 seconds that I'm seeing here. If I see a plateau, I know that people are waiting for more than 30 seconds. Memory. Let's see. What I'm looking for in memory, the first one is the target server memory versus total. So target is essentially your max memory, and the total is what operating system is giving to SQL Server. So if these lines are pretty much consistent, then I'm very comfortable with it. If for some reason SQL Server is not getting its allocation, either there's not a demand for the memory, or there's some other process that is consuming memory. And I've seen that on a few systems. Page life expectancy, the sawtooth pattern, is something that I normally see. It does seem to reset right around the beginning of the day. If I see a lot of sawtooth occurring and it stays really low, then I know that there's some memory contention happening. And then last one, and this is something that we saw at Peacock Alley, as we saw memory grants pending. And this is really similar to the saturation that we see with processors. If we see spikes in here, spikes are okay, but if you see something that's sustained, it's a problem. And this actually will appear as blocking without having a blocked process within SQL Server. And that's what we were seeing at Peacock Alley. So if you see in any of these saturation counters, if you see a plateau, people are waiting on it. This next section that I've got listed as systems, it's pretty lots of data, but if you look, so this is where the device instance comes in, and you can see the server name and then the instance name. So across this entire visual, I can see all of my servers and their average processor by hour. So they percent processor time by hour. And this really lets me know that across the entire system, my load is on the Sage proc server. And I can see that the rest of the servers aren't anywhere close to it. Got the same thing every 5 minutes. You're going to be spikier every 5 minutes, and you can see that I bump up. Again, if I get above 70% in a 5-minute period, that's what I'm concerned about here. And I've actually heard, and it's something that I want to investigate, on virtual machines, we actually want to keep our processor percent between 50 and 60 because of the way that the virtual machine host is actually scheduling, that it down schedules, gives less priority to your processors that don't have very much load on them. So to ensure that you get good responsiveness, you want to have more consistent and kind of in the 50 to 60. So on this particular system, we may want to have less processors per machine so that we get better scheduling. This is using the Multiline Tool again. And again, this is processor queue length, and it's looking at that across all of the systems for a particular day. This is looking at network traffic across all of the machines. So I can see which machines are receiving network traffic, which ones are sending network traffic. And then this is a saturation counter, the output queue length. And again, that's 0. So I don't see any contention that's occurring. And if you look at the figures that we have in here, you know, the peaks are around 10 megabytes per second. That's not a saturation type of number that we need to worry about. And the last piece is this Explorer. Again, this is kind of what I was putting in before. You can go through and use an Explorer to limit down what you're seeing in the counters, and something's going on that I'm not sure what it is. So I'll get that figured out and let you know. So let's go back to the PowerPoint. I know that we're drawing in close to our time. We talked about creating visualizations. I went through initial analysis, looking at that package. So I think I've actually gotten through everything pretty well.